Good afternoon, everyone. Welcome to kind of the second to last talk of GDD India. My name is Mike McDonald. I'm a product manager on the Firebase team, and I'm joined with two of my colleagues, Todd and Dan. And we're here to do a brief overview of how to build an app with Firebase. Let's start with the premise of this app. So many of you are probably multilingual, English and a number of other languages. I am actually terrible with languages. I speak English passably, and unfortunately, I travel quite a bit for work. And so that's, as you can imagine, probably pretty difficult, right? If I want to go to a restaurant and order something, I just kind of point at things on the menu, or maybe I use Google Translate and try and translate it. But it'd be really nice if I could actually talk to people and have them understand what I'm saying. This is a problem that science fiction, in particular, has been trying to solve for decades. Right? If you read a number of science fiction novels, if anyone has read, for instance, Hitchhiker's Guide to the Galaxy, there's a little device called the Babelfish where you can put in your ear, and immediately everything that everyone is saying is translated to your language, and everything that you're saying is translated to theirs. Science has actually gotten pretty close to that. So I saw a demo a couple years back of a peer-to-peer communications tool. And the demo was a bunch of kids in the United States talking to a bunch of kids in somewhere in South America, and the kids were speaking in English, and the kids in South America heard it Spanish, and vice versa. Some of you may actually be thinking, wait, hasn't Google already solved this problem? So the Pixel Buds, if you've seen those, came out a little while ago. Put the Pixel Bud in your ear, tap it, and it'll automatically translate to your language. But both of those took years, right? And we have 30 minutes to build an application. Let's see if we can do that much faster, using something that we all have today, right? We all have smartphones, so we're going to build an Android app and an iOS app where you can select the language that you speak and want to hear, and then we will do all of that translation automatically for you. So how are we going to do this? Right? If you didn't come to this talk, you might start building something that looks like this. So this is kind of the traditional mobile application. You have your mobile app that talks via REST requests to some Python or Django or PHP server that then proxies requests out to your translation APIs or your databases or your file storage systems. Unfortunately, there are a lot of problems with this, right? So who is going to kind of manage and maintain those servers? Who's going to even get you the server in the first place? What about uploading files over really flaky networks, right? I'm sure we've already been having conference Wi-Fi issues. How are you going to make sure that those files are uploaded appropriately? What about authentication? What about performance and scalability, right? So if we take this app, give it to you guys, and then it goes viral, is everything going to scale? Is it going to keep working? Who knows? Luckily, everyone came to this talk. So you're going to learn about how Firebase solves all of those hard problems. Unlike the apps that we saw on the previous page, Firebase applications are not traditional applications. Firebase eliminates that middle-tier server and lets your devices talk directly to our powerful managed cloud services. We handle things like client-side authentication and flaky networks, so there's no need to build resumable protocols or do your own OAuth flows. And Firebase scales automatically, so the app that you build for a prototype will scale to production the next week. Firebase's smart clients handle all of those hard problems, so you can focus on building applications that your users love. So in case you haven't been paying attention over the last 2 days, and you're like, what's Firebase? Firebase, very briefly, is Google's mobile platform. It provides tools that help you develop your applications on Google Cloud Platform, understand what your users are doing in those applications, and grow an engaged user base. But we can't build an app using all 19 of these features right now. I'm going to turn it over to Dan, who's going to pick and choose a few of these and show how we can build our app. Over to you, Dan.
Thanks, Mike. So a core tenet of Firebase is that you can pick and choose the pieces that you need. So I'm not going to explain all those orange circles. I'm going to pick the 3 that we're going to need to build this app. The first one is a highly scalable object storage that lets you upload exabytes of user-generated content. We're going to couple this with Firebase Auth, which is a serverless authentication system to handle all those complex social flows and session management with ease. And the third one that I'm going to use is a NoSQL document-oriented database called Cloud Firestore that stores and syncs JSON-like data. So let's see how we can piece these three things together. Since we need to record audio and share it with other users, we need to store the file somewhere secure that's also accessible across multiple devices. Cloud storage is the right solution for that, and it comes with Firebase SDKs. It's easy to select a file on your device and upload it directly from anywhere. We have client-side SDKs in 5 languages: Android, iOS, JavaScript, Unity, and C++, so we can meet you where your app is. These SDKs are smart and handle poor mobile connections, pausing and resuming uploads to make sure your file is uploaded. Once that file is uploaded, you can download the content directly from any cloud storage bucket across Google's global network. The same robust support from the Firebase SDKs enables you to do this. So we've uploaded the audio file to the cloud. How do you know who is allowed to have access to it? And that's where Firebase Auth comes in. Firebase Auth lets you log in your users with the common social providers, or your own email and password system, or any provider using our custom authentication experience. Instead of spinning up servers to handle multi-legged OAuth flows, our simple client-side SDKs handle all the flows and securely authenticate your users. We've also recently introduced phone number support, so you can SMS your users to sign in. This feature is really popular in India and other emerging markets. Firebase also provides an open-source, pre-built set of UI components, like the above, that give you access to a seamless sign-in experience right out of the box. It doesn't matter if your users are on Facebook, GitHub, or use email and password. We always create a user record with a single ID across all their accounts. Again, this happens entirely on the client side. No need to write your own OAuth integration. By using Firebase Auth, all your users are logged in order to upload files, no matter where they came from. So now we've been able to upload and download files securely. How do we go about synchronizing the file metadata and ensuring that other users get notified when there's a new translation? Luckily, Cloud Firestore has us covered here. Cloud Firestore is Google's newest database. It's a real-time, highly scalable, document-oriented database. We'll be storing data in several collections: an uploads collection, a transcriptions collection, and a translations collection. Uploads is going to hold a link to the file we uploaded to cloud storage. Transcriptions is going to handle the text representation of that file. And lastly, in translations, we're going to handle all the translations for that transcription. And we'll see how these all connect shortly. Unlike other databases, which are often request-response style, Cloud Firestore pushes changes to clients in real time. Simply attach a listener to a collection, and we'll notify you anytime data changes. Let's switch to code to see how these pieces help Mike build an app. So the app we're going to build has a login button. It has a spinner that lets us select the language we want to hear, a record button, and finally, a text field showing the translated text. On the developer side, we're given an audio file, and we expect a snippet of text that we can play out loud. We've already imported Firebase using Cocoa Pods and Gradle and configured Firebase within the app. The first thing we need to do is upload the file. We create a reference that points to the file and add associated metadata like content type. We take the local file and upload it. Then add listeners on success and failure. On failure, we'll print out an error message. On success, we'll write the file metadata into cloud storage. Cloud storage is secured by default, so we'll have to be authenticated to access it. Auth is critical to any app and is really hard to get right. Since Mike's a product manager and wants this app done yesterday, we're going to cheat a little bit and use an open source library we built called Firebase UI to implement the auth flows. The first thing we do is set Firebase UI up and configure it to use Google. We'll also add some business logic and check if the user is already logged in. If they aren't logged in, we'll launch that login flow. Otherwise, we'll listen for new translations. Now that we've uploaded files securely, we need to listen for changes when a new translation is available. Since we already wrote the metadata to the database after we uploaded it, we need to listen for new translations in our database. To do this, we'll create a reference to our database, add a document listener to get new translations. In the body of our listener, we'll fetch the specific language from the database. After that, we'll simply use the text-to-speech APIs on each device to play the translation. Let's try that out. So Mike and Todd are going to compile their applications.
Testing, 1, 2, 3. It's not getting it for some reason.
Oh, OK, live demos. But I heard machine learning is pretty hot these days. So let's see if there's anything Google Cloud can do that can keep Mike from becoming our backend. Todd, do you have any thoughts?
So let's write some software to fill the gap. Mike wants a universal translator app, and right now we just have an app that parrots speech back to us. And let's do that in the trendiest way possible, by adding some machine learning. But designing and training our own models it takes a lot of time, and that's not what this talk is about. We want to get things up and running fast. So that's where pre-trained machine learning APIs come in. We can pick from a big menu of APIs that are available as part of Google Cloud Platform, and they're really cool and solve a bunch of problems, including two problems our app faces today. One of those problems is transcribing voice into text, and for that we're going to use the Cloud Speech API. And for translating one language into another, we're going to use the Cloud Translation API. So our problem's solved, right? Well, not totally. How are we going to use these really cool APIs and get them wired into our app? Traditionally, Firebase apps are serverless, so this means that there's no backend that you could bake it into, which is great. But as your app gets more and more complex, you're going to start facing challenges faced by a lot of app companies. One of those challenges is secrets. Users can learn a lot from the files that make up your app, be it pre-release code for your game or API keys like the ones that we're going to use for the cool APIs. Also, the resources on the phone. Although the CPU itself is pretty fast these days, the battery life is only limited, and it can crunch only so many numbers or translate so many phrases. And finally, code sharing. One of the most painful things about being a mobile developer is having to implement the same functionality across multiple platforms. Our app faces all three of these challenges, and we can mitigate them by moving our secrets and the code-intensive functionality into the cloud. And since it's in the cloud, we'll only have to implement it once rather than for each platform. If we dipped into our old bag of tricks, we might solve it this way. Spin up some servers on Compute Engine, create APIs backed by Django or Node.js. But in the end of the day, that results in even more complexity. You'd have to deal with caches, microservices, and load balancers. And before you know it, we're back here with a lot of complexity, not where we intended to be. So instead, we're going to use Cloud Functions. It'll give us the minimal glue that we need to deal with our app's serverless challenges. But instead of showing you in a silly diagram, we're going to prove it by building the app live. So we're going to write a Cloud Function, which, unlike a mobile app, really doesn't require much to get started, just a few variables and a function stub. Can we switch over to the demo? So first, we'll start by adding a function that triggers when the document is written into the database. From there, we run a function that will extract the metadata from that actual file. This includes the language, the encoding, and the sample rate. Then we will send that recording to Cloud Speech API. by pointing the Cloud Speech API to the specific location in cloud storage. Once we get a result from the Cloud Speech API, it'll include the transcript, and we take that transcript and write it back into the database. Once we have the transcript, though, we still need to translate it. So we're going to do pretty much the same thing as before, but with the Cloud Translation API. So we're going to attach another function that triggers when the transcript is written into the database, and then when it runs, it gets the language, and we iterate across the languages that our app support and send a request to the Cloud Translate API for each one. As they're translated, we write them back to the database, and once all the translations are complete, we signal that the function is complete. So basically, a deploy is very simple. It takes a few minutes, and we know that your time is precious. So here's one that we prepared earlier. You write Firebase deploy, and pretty much we do the magic. Now I'm going to hand it back to Mike.
Thanks, Todd. So the demo's been acting up a little bit, so we're not going to do that, unfortunately. But what's going to happen is, again, upload the files, goes through Firestore, all of the magic in our functions happen, and then it gets the language spit back out. That was pretty cool. I promise it does work. We're having a little bit of flakiness over the internet. But you can actually go on GitHub. If you look for Zero to App Universal Translator, you can get all the code and build it yourself. So we just built 2 apps in about 20 minutes, complete with our own backend. If you hadn't come to this talk, you might have built something that looks like this, right? Your application talks to that server and proxies everything out. But that costs a lot of money, takes a lot of time, and requires that you get paged at 2 in the morning if your servers go down. You don't want to do that. You want us to own that management. Dan showed us how to replace that with Firebase and allow your application to talk directly to our various services in order to build serverless and management-free applications. Then Todd came up and explained how to add cloud functions to supercharge your application by adding the rest of Google Cloud Platform, including the Cloud Speech and Cloud Translate API, to securely and performantly build the rest of that application. Just as easy as it was to integrate both of those APIs, it is equally easy to add additional Google Cloud Platform services, including other pre-trained ML APIs or your own either ML or additional cloud products. And as you saw, it's really easy to chain events together to turn complex processes into really simple applications. So thank you all for coming. If you have additional questions, we'll all be right behind at the speaker zone area. And thank you all very much, and enjoy the rest of the talk, or enjoy the rest of the conference.